All right, I'm going to show you how to do checkpoint 8. The green box is super simple. It's just some review questions that'll help you understand what's going on in the lab. So answer all the questions. There's video help for every single question if you need it. And then the B&A questions are there too. The blue section is the actual lab. So we're going to click on this link and it should set up simulation to show how radio waves and electromagnetic fields work and are created. Takes a little longer than the other ones. It has to kind of load up. It's an older simulation, but give it a minute and it should be good, like you'll see here. And it even looks a little older than the ones we've been using. All right, so this is where we want to be. And then we're going to read through here. It says wiggle the KFET transmitter's electron. So it's important that we understand what's what. The left side here, this side, KFET, this is a radio station, and this is the transmitter. It's what's going to create the radio waves, and this is just somebody's house, so it's the receiver. It's going to receive those waves. And the question says, wiggle the electron. So I'm going to move this up and down and see what happens. So you'll just describe what happens after I wiggled that up and down, and that'll be number 1. You can't really tell this without knowing it, what kind of fields are created. So there's video help if you don't know what kind of fields are created when electrons vibrate or wiggle. You might remember it, might not, but there's video help in case. Now off to the side, the right side, we're going to have to make sure we do what it asks. It says set the field display to full and transmitter movement to oscillate. So if you look, full is right here. So I'm going to click that. And then oscillate is up at the top. So I'm going to create that. And now remember, those are vectors. The bigger the lines, the longer the lines, the stronger the field, the force, and the direction of the force is where the arrows are pointing. So you're going to describe what happened there. You can talk about vectors if you want, but really just describe what happened on the screen. 4 says set the display type to curve. So we're going to change it to curve. And then it says move the frequency and amplitude around. You have to do both. So I would move the frequency to a low frequency and describe what happens as you change it from high. In other words, at a low frequency, this is what I see. At a higher frequency, this is what happens. So you can just move the frequency bar left and right. And then for the answer after that, you'll do the same with the amplitude. All right, next it says set the field display to curve with vectors in radiated field, which is already clicked, and it says to click on electron positions at the bottom. This is a button you should be able to move it. You might want to just look here. Sometimes it's easier as you change things. But every time you change a scenario or move any new button, you're going to have to unclick and click this again to get the graph to change and show up. All right, now that we've done all those things, it says describe what is happening in the transmitter and receiver. Remember, transmitter is what's happening over here, or if you look at this part, this graph, versus the receiver. So you're going to want to describe the differences you see here. It's probably easier to look at this graph. The next questions are all about reading what it says and then telling us what happens. And this is where I said you want to click that electrons box off and back on every time you do one of these, because it's going to tell you exactly what to do. If you increase the amplitude, what happens to the wavelength? So you're going to increase the amplitude up here and then tell me what happens to the wavelength. Remember, wavelength is top to top. So as the amplitude increases, does the wavelength increase, decrease, or stay the same? How long the wave is. All right. If amplitude increases and frequency stays the same, the electron at the receiving antenna on the right, or the bottom graph, has a larger peak, but oscillates at the same frequency. Is that true or false? Again, you're going to increase amplitude and then look for it. What they're saying is the frequency shouldn't change. So how many waves, how many peaks you see at the bottom should not change. If that's true, and that's what you see, you're going to highlight true. If it's false and you see a different amount, you're going to hit false. What happens as frequency decreases? The wavelength decreases. So how are we going to test that? Same thing. Lower the frequency bar right here and see if the wavelength, the distance between the tops of waves, decreases. If it does, that's true. If it does not, it's false. Number 9, when the electron in the transmitting antenna is at its peak height, the receiving antenna is also its peak height. It's much easier if you look at this then. So they're saying when one is the highest, the other below it is also the highest. If that is true, you're going to click true. If it's false, you'll click false. Then you'll do the BA questions, hopefully, and then you're all done with this